Alright, in this video we're going to talk about section 7.2, the sum and difference formulas. Just like we had in the previous section, section 7.1, where we started off with this definitions, a definitions box, it's also really important that you remember these identities. Just like in the previous section, you should remember those other identities as well. As we go through the problems in this section, I highly recommend that you keep these definitions close by. They're definitely going to come in very, very handy. Another thing that you should probably keep close by, unless you already feel comfortable with it off the top of your head, is the unit circle. We went over the unit circle before in a previous section. Here it is again, just really quickly. I highly recommend that you know the values for both the sine and the cosine for the different angles for this unit circle. Those are definitely going to become really, really, really important in this section. So let's go over these. So first off, what we're looking at for the sum and difference identities is whenever we take the sine or the cosine or the tangent, but what we're taking the sine, cosine, and tangent of are the sum or the difference of two angles. So here U and V are considered to be angles. So whenever we take the sum of two angles or the difference of two angles, that's going to help us out a lot of times whenever we're looking at a strange angle, say like the sine of 105 degrees or something like that. That wouldn't be on the unit circle. How can we change that so that we have the sum of 2 degrees that would in fact be on our unit circle? So here we have those properties for whenever we have the sum of two angles. Here to the right hand side of the equality we have for whenever we have the difference of two angles. And again, we're just going to be referring back to this a lot in this section. So here it says, find the exact value of each of the following using the sum or difference formulas. We have the sine of 120 degrees plus 135 degrees. So what we could have done, and this is something that we're going to do here in a couple of minutes, but what we could have just as easily have started off with is the addition of these two. So for 255 degrees. So if I ask you what the sum of 255 degrees is, you might say, well, I have no idea. Well, one of the things that we can do is we can break this apart to the sine of 120 degrees plus 135 degrees. And now we can use one of the properties that we have up here for the sum of these two angles. So it's the sum of these two, so therefore this is the same thing as saying sine of 120 degrees cosine of 135 degrees plus the cosine of 120 degrees times the sine of 135 degrees. So I'm just using this property up here. Well, the sine of 120 degrees, this is now where the unit circle comes in handy. That's the square root of 3 over 2. Cosine of 135 degrees is negative square root of 2 over 2. Plus the cosine of 120 degrees is negative 1/2. And the sine of 135 degrees is the square root of 2 over 2. And now we get to something that's just a bunch of numbers. So this just comes down to arithmetic now. This is going to come out to negative square root of 3 times square root of 2 over 4 minus the square root of 2 over 4. If we multiply those two things together. So then this is going to become negative square root of 2 minus the square root of 6, or really vice versa if you want to stick to the same format that we have over here. Either way, these are going to be divided by 4. Alright, let's go on to number 2. Sine of the quantity pi over 6 minus pi over 4. So now we know that this is then going to be same thing as up here, we're going to use this property. It's going to become the sine of pi over 6 times the cosine of pi over 4 minus the cosine of pi over 6 times the sine of pi over 4. We know that the sine of pi over 6 is equal to 1/2. Cosine of pi over 4, square root of 2 over 2, minus square root of 3 over 2 times the square root of 2 over 2. Now we can just do some arithmetic to this. This is going to become the square root of 2 over 4 minus square root of 3 times the square root of 2 over 4, which again is this. Or we can just have square root of 2 minus the square root of 6 all over. Oops, this got cut off. So sorry. So let me talk my way through this here again, since you couldn't see some of this stuff. But we know that these are what we get from the unit circle for those respective sines and cosines. And now what we can do is we can start to do some arithmetic to this to try to simplify this. But when we multiply these two things together, we get the square root of 2 over 4. When we multiply these two things together, we get square root of 3 times the square root of 2 over 4. Since they have the same denominators, I combine them down here. And square root of 3 times the square root of 2, simply just the square root of 6. Alright. So now for the cosine of 225 degrees minus 150 degrees, this is then the same thing as the cosine of 225 degrees times the cosine of 150 degrees. I'm just using one of the properties that we had above. Plus the sine of 225 degrees times the sine of 150 degrees. And again, for any of these, just as in any other lecture video, you can pause the lecture video, make sure that you can do these by yourself, identify what property that we're using in that property box above, and also now try to use the unit circle to try to remember what these individual sines and cosines come out to be. Here we're going to get that this comes out to negative square roots of 2 over 2. This is going to be negative square root of 3 over 2. Then plus the negative square roots of 2 over 2. And this comes out to 1/2. So now if we do this arithmetic, this is going to be the square root of 2 times the square root of 3 over 4. And over here, then we're going to get minus square roots of 2 over 4. These have the same denominator, so we can call this the square root of 6 minus the square root of 2 over 4. Alright, let's go on to the next page of notes. And here it says, find the exact value of each of the following expressions without the use of a calculator. Alright, so let's see here. Hold on a second, did I skip a page? I think I skipped a page because now all of a sudden we're at number 8. Yeah, here we go. Here, this is number 4. So, skipped a page, let me backtrack here. And it says, use the sum and or difference formulas to simplify down to one expression, then find the exact value of each expression. So now we're just going in reverse. So we have the sine of 12 degrees and cosine, then we have plus the cosine of 12 degrees plus the sine. So therefore this is going to be equal to the sine of the addition of these two angles. Well, if we add these two angles together, then this is going to become sine of 90 degrees. And the sine of 90 degrees we know is just equal to 1. Alright, so now let's take a look at this next one. We have cosine of this times the cosine of that plus the sine of this times the sine of that. So therefore, we know that this is the same thing as saying the cosine of the difference of these two angles. And if you take 7 pi over 12 and subtract 5 pi over 12, we're going to get 2 pi over 12, which is just the same thing as saying the cosine of pi over 6 and the cosine of pi over 6 using the unit circle we know is square root of 3 over 2. Now lastly, we have the tangent of 260 degrees plus the tangent of 40 degrees over 1 minus the tangent of 260 degrees times the tangent of 40 degrees. So therefore, here we know that this is going to be the same thing as the tangent of these 2 degrees added together. And if we take these 2 degrees and add them together, we're going to get the tangent of 300 degrees. And the tangent of 300 degrees is the same thing as the sine of 300 degrees over the cosine of 300 degrees. And this is then negative square root of 3 over 2 divided by 1/2, or it just comes out to negative square roots of 3. Alright, let's go on to the next part. It says, since we only have exact values for multiples of 30 degrees and 45 degrees, it's meaning in the unit circle, or pi over 6 and pi over 4 if we're dealing in radians, just in terms of pi rather. And we need exact values in the identities we use, then we will need to rewrite other angles using combinations of these. For example, 15 degrees we can rewrite as 45 degrees minus 30 degrees, or 60 degrees minus 45 degrees. So what we're trying to do is get them down to multiples of 30 degrees or 45 degrees. So then in number 7, and for the next couple examples, or at least for 7a, b, and c, it says, rewrite each of the following using multiples of 30 degrees and or 45 degrees. Alright, so we're just going to stick to 30 and 45 degrees. And then at the bottom we have one here in terms of pi, so then we're also going to do it in terms of pi over 6 and pi over 4. So for A, 30 or 75 degrees, we can rewrite this as 30 degrees plus 45 degrees. So that was a pretty simple one. And for negative 105 degrees, we can rewrite this as 30 degrees minus 135 degrees. Or simply, we can rewrite this as 30 degrees minus 45 degrees minus 45 degrees minus 45 degrees, which is just the same thing as 30 degrees minus 3 times 45 degrees. Then for C, we have 5 pi over 12, which we can then break apart to 2 pi over 12 plus 3 pi over 12. And again, try to remember, we're trying to get this to either pi over 6 or pi over 4. So therefore, 2 pi over 12 is just the same thing as pi over 6. And 3 pi over 12 is just the same thing as pi over 4. Alright, let's go on to the next page of notes. Because now what we're going to start to do is kind of what I foreshadowed earlier. We're going to take trig functions of angles that we wouldn't necessarily find on the unit circle, and we're going to try to convert those to angles that we would find on the unit circle. So here, cosine of negative 75 degrees, we can rewrite that as the cosine of 60 degrees minus 135 degrees. Both of which we can find on our unit circle. So now if we wanted to figure out what this was using the unit circle, well, here we have two angles that are being subtracted, and we're going to take the cosine of all of this. So we can rewrite this then as the cosine of 60 degrees times the cosine of 135 degrees plus the sine of 60 degrees times the sine of 135 degrees. Now using the unit circle, we get that this is 1/2 times negative square roots of 2 over 2 for these first two terms, plus sine of 60 is equal to the square root of 3 over 2 times the square root of 2 over 2. We can now do some arithmetic to these or some algebra to these, and this is going to become the square root of 2 over 4 plus the square root of 6 over 4, or the square root of 6 minus the square root of 2 over 4. Alright, let's take a look at number 9. Again, remember that for number 9, we're trying to get it to be something that has pi over 6 or pi over 4 or multiples of those. So therefore, we can rewrite sine of 7 pi over 12 as the sine of, let me give myself a little bit extra room here, the sine of 9 pi over 12 minus 2 pi over 12, which is just the same thing as the sine of 3 pi over 4 minus pi over 6. Now we have the sine of the subtraction of these two angles, so therefore this is going to come out to the sine of 3 pi over 4 times the cosine of pi over 6 minus the cosine of 3 pi over 4 times the sine of pi over 6. And now again we can figure out what these angles are, or these trig functions are, using the angles on our unit circle. And this is going to become square root of 2 over 2 times the square root of 3 over 2 minus the negative square roots of 2 over 2 times 1/2. And if you do this, this is going to come out to square root of 6 over 4 plus square root of 2 over 4, or simply just the square root of 6 plus the square root of 2 over 4. Alright, let's do number 10. 10 has the tangent of 15 degrees. If I ask you what the tangent of 15 degrees is, chances are you don't know that off the top of your head. But what you do know is that 15 degrees we can rewrite as 45 degrees minus 30 degrees. And now the tangent of these 2 degrees that are being subtracted, we know that we can use one of the identities, and that is that the tangent of 45 degrees minus the tangent of 30 degrees over 1 plus the tangent of 45 degrees times the tangent of 30 degrees. Alright, so let's see here. Using our unit circle, this becomes a little bit complicated, but the tangent of 45 degrees is just 1. The tangent of 30 degrees is the same thing as the sine of 30 degrees over the cosine of 30 degrees. Now here in our denominator we get 1 plus tangent of 45 degrees is still just 1. And then just like we had above the tangent of 30 degrees, we can rewrite that as 1/2 over square roots of 3 over 2. if you do all of this arithmetic and simplification, you're going to get that this comes out to the square root of 3 minus 1 over the square root of 3 plus 1. And technically we shouldn't have radicals in the denominator, so we can go through and we can multiply these by square root of 3 minus 1 over square root of 3 minus 1 to try to simplify this out here a little bit more. But we're kind of running out of room here. And the important part about this is to go from this step right here to this step right here. The unit circle stuff in this is something that comes from a previous section. So we'll stop here even though that's not completely simplified. Alright, let's take a look at number 11. Suppose that the terminal side of angle alpha lies in quadrant 4 and the terminal side of angle beta lies in quadrant 3. If cosine of alpha is equal to 4 over 7 and sine of beta is equal to negative 8/13, find the exact value of the cosine of alpha plus beta. Alright, and he gives us a hint here. It says, find x, y, and r for alpha and x, y, and r for beta. So let's do that. Let's start off with that. If we have alpha right here as our angle, then the cosine of alpha is equal to the adjacent over the hypotenuse. So then we can call this right here y. For beta, call this angle right here beta, then the sine of beta is equal to the opposite over hypotenuse. So then we'll call that negative 8/13, and we'll say that we don't know what this x side is right here. Therefore, so I know that this negative sign right here is a little bit strange for the length of a triangle, side of a triangle, but we're going with it for right now so we can figure out what x is and also here what y is. So for y, we're then going to get 4 squared plus y squared is equal to 7 squared. So therefore y squared is going to be equal to 49 minus 16 is equal to 33. So therefore y is equal to the square root of 33. And for x, we're going to get that x squared plus negative 8 quantity squared is equal to 13 squared. So therefore x squared is going to be equal to 169 minus 64 is 105. So therefore x is going to be equal to the square root of 105. So then what we know is that if we're trying to figure out the cosine of alpha plus beta, this is the same thing as the cosine of alpha times the cosine of beta minus the sine of alpha times the sine of beta. And the cosine of alpha, we know, is then going to be 4 over 7. That's what we're given. Cosine of beta, so now we're looking for the cosine of beta over here. It's going to be adjacent over hypotenuse. We figured out that x was equal to 105 and our hypotenuse is still 13. So these are going to be multiplied. Now the sine of alpha is going to be opposites, right? So now we're over here, opposite over hypotenuse. And the sine of beta, we were already told that that is equal to negative 8/13. Now, if we figure all this stuff out, this is going to come out to 4 square roots of 105. We have the same denominator, 7 times 13 is 70 and 20 was 91. And then here we're going to get minus times a minus becomes a positive, so it's going to become 8 square roots of 33. And we'll leave it as this right here. All right. So again, the process of this was to find these different sides that we didn't know of these respective triangles, so that once we try to figure out what it was asking us to do to find the cosine of alpha plus beta, we could figure out what we didn't know, the cosine of beta, and also the sine of alpha. All right, let's go on to the next problem. Suppose that alpha is an angle such that the tangent of alpha is equal to 5 over 7 and the cosine of alpha is less than 0. Also suppose that beta is an angle such that the secant of beta is equal to negative 4 over 3 and the cosecant of beta is greater than 0. Find the exact value of sine of alpha plus beta. Alright, so let's do it again like we did before. Here, if we have that this is alpha, then for alpha, we have that the tangent is 5 over 7. And the tangent is defined as opposite over adjacent. So therefore, we're going to call this right here as 5 over 7. But now the important thing is that the cosine of alpha is strictly less than 0. And in order for the cosine of alpha to be less than 0, here we're going to call this our hypotenuse, but therefore this has to be a negative 7 right here. Right? That's only going to be the case if the cosine of alpha is strictly less than 0, but the tangent of alpha is still equal to 5 over 7. Now if we look at beta, here if this angle is beta, then the secant is equal to negative 4 over 3. But we want to have that the cosecant of beta is strictly greater than 0. So therefore, we know that for the secant, that this is then going to be 4, and this down here is going to be negative 3. Since the secant of beta is going to be the hypotenuse over the adjacent. So then here we don't know this side y. Alright, so let's try to figure out what h and y are. So h squared is going to be equal to 5 squared plus negative 7 squared. So h squared is going to be equal to 25 plus 49, which is equal to 75. So therefore h is going to be equal to the square root, 74. So it's going to be equal to the square root of 74. Now we're going to have 4 squared being equal to y squared plus negative 3 squared. So then here we're going to get that this is 16 minus 9 is equal to y squared, or y is going to be equal to the square root of 7. Right. So now if we were trying to find the sine of alpha plus beta, then we're going to have that this is the sine of alpha plus the cosine of beta plus the cosine of alpha times the sine of beta. So if we plug these values in here, this is going to come out to negative 5 over the square root of 74 times negative 3 over 4 plus negative 7 over the square root of 74 times the square root of 7 over 4. And again, I'm just using the concept of sine and cosine using these angles up here. If we do some arithmetic with this stuff, we're going to get that this comes out to 15 minus 7 square roots of 7 divided by a common denominator of 4 square roots of 74. All right. So for just to make sure that we're clear on how we got that the secant was this, but to make sure that the cosecant here is positive, right? Let me backtrack and talk about that here for a second. Because what we're saying is that the secant of beta, we know that that is equal to 1 over the cosine of beta. And we're saying that that is equal to negative 4 over 3. And we also want that the cosecant of beta is equal to the sine, 1 over the sine of beta, and we want that this be strictly greater than 0. So the only time that this is going to happen, or if we want to make sure that this happens, then we need to have, for beta, we need to have that the sine is positive, which we have right here, and also for the cosine, I believe that we already talked about that the cosine has to be negative, so that's why we left a negative sign here. So that's why we didn't have that this right here was a negative value, but instead a positive value, and why this one over here had to be a negative value, since we wanted this right here to be strictly positive, but this up here to be strictly negative. Alright, let's go on to number 13. Find the exact value of this, the cosine of the quantity tangent inverse of 1 plus the cosine inverse of 1/2. Alright, so remember, let's first look at these inverses. This is something that we talked about in a previous section, so let's try to jog our memory. But whenever we have that the tangent inverse of 1, what we're looking to find is the angle to take, the angle such that if we take the tangent of that, that is equal to 1. We know that tangent is the same thing as the sine of theta then over the cosine of theta. And if we want this to be equal to 1, then the angle that we're going to use for theta is going to be 45 degrees. Since we know that the sine of 45 degrees over the cosine of 45 degrees is simply just equal to 1. And again, remember that I'm going to say that since the range of the tangent inverse must be in negative pi over 2 to pi over 2. This is what we talked in a previous section in chapter 7. So it's still in this chapter. And now if we look at the cosine inverse of 1/2, what we're looking to find then is the cosine of some angle theta such that is equal to 1/2. Well, the angle that we're going to use then is going to be 60 degrees. Again, since the range of the cosine inverse must be in 0 to pi. So therefore, what this is asking us then is to find the cosine of 45 degrees plus, right, that's what we found that theta right here must be. So this then is equal to 45 degrees. And this right here, we just determined is equal to 60 degrees. So then this is going to become 45 degrees plus 60 degrees. And now we're just right back down to concepts that we have in this section, right? These two things were concepts from previous sections. Now this is just a concept from this section. And we know that using the identities from this section, this is going to become the cosine of 45 degrees times the cosine of 60 degrees minus the sine of 45 degrees times the sine of 60 degrees. And using the unit circle, we have that this is the square root of 2 over 2 times 1/2 minus the square root of 2 over 2 times the square root of 3 over 2. So therefore this is just the square root of 2 over 4 minus the square root of 6 over 4, or just the square root of 2 minus the square root of 6 over 4. And that is the last problem for this section. The next problems are the practice problems, but that is left to you. So please make sure that you feel comfortable, not just with the identities that we saw at the beginning of this section in that box, but also with the concepts that we talked about previously, especially if some of this stuff that we did up here was figuring out what sides have to be positive and negative. That's a little bit so fuzzy for you. Make sure that you go back and take a look at the unit circle sections. But that concludes this lecture video.